Welcome to the video on the ideal gas equation. So by the end of this video, I'd hope that you would know the ideal gas equation, and what I mean by that is you'd be able to write down what the formula is if you're asked to. I want you to be able to use it, and also, this is very important, to be able to convert units for pressure, temperature and volume between different units. That's important because for the ideal gas equation, you have to use numbers in certain units, and they might ask for your answer to a problem in a different unit, and you have to know how to convert between those two things. So the ideal gas equation is basically an amalgamation of two different laws. The first law is Boyles Law, which states that the volume of a gas is inversely proportional to the pressure of the gas at a constant temperature, which basically means that if we increase the pressure of the gas, then the volume will decrease. The other law is Charles's law, which states that the volume of a gas is directly proportional to the temperature at a constant pressure this time, which basically means that if we increase the temperature of a gas at a constant pressure, the volume will also increase. If we were to merge these two laws together, then we end up with the ideal gas equation. Now, you don't have to know how the ideal gas equation came about, so ignore the stuff about Boyles Law or Charles's Law unless you're interested in it and you want to look it up further. But the basic thing you have to know is the ideal gas equation, and that is PV equals nRT. Now, I can see that there's more letters now than were previously in the two laws that made this up. So I'm just going to explain what all these letters are. So first, P stands for the pressure. And that is always in pascals. V stands for the volume. And that is always in meters cubed. N stands for the number of moles. And that doesn't have a unit, it's just a number. R is known as the gas constant, and that is the same at all times, and that is 8.31. And then the temperature, T stands for the temperature, and that is always measured in Kelvin. Now, it's very important that you remember both what the letters stand for. So P is pressure, V is volume, N is number of moles, R is the same, always 8.31, that's given to you in your exam, and T is temperature. Not only those, but also the units that are used. So pressure is always pascals, volume is always meters cubed, and temperature is always Kelvin. The reason why that's important is because if you're given a question on this, they won't always give you numbers in those units. You have to convert them first, and that is something else we'll talk about a bit later in this video. If you haven't come across Kelvin before, that is basically a unit that is used that is based on the absolute value of temperature. And what that means is that it's based on the fact that 0 Kelvin is the lowest temperature you can have, and then it works up from there. The difference between 1 Kelvin and 2 Kelvin is a Celsius. The gap between Kelvin is the same as a Celsius, but it's just different that the 0 is set at the minimum temperature you can have, rather than at the freezing point of water, which is what is used for Celsius. So let's have a go at an example then. So here we are asked to work out the total number of moles of gas produced in this reaction, based on the fact that the gas is produced occupied a volume of 3.5 times 10 to the minus 3 meters cubed, at a pressure of 100 kilopascals, at a temperature of 31 Celsius. And the first thing I would always do is write out the ideal gas equation for these questions, because you always get a mark for that. You see there's 3 marks for this, so you look down here, there's 3 marks. So the first mark is always for writing out the ideal gas equations. That is PV equals nRT. The next thing I would do is write down everything that you know. So I'm going to write down P, V, N, R, and T up here, and write down what those numbers are. Now, P stands for pressure, and you're told that the pressure is 100 kilopascals. Now, if we went back a slide, then you would see that pressure in the ideal gas equation is not inputted in kilopascals. You make sure you use that number in pascals instead. And to convert from kilopascals to pascals, you have to times by 1,000. So instead of 100, the pressure is going to be 100,000. V is volume, and that is given to you here. And that is 3.5 times 10 to the minus 3 meters cubed. Now again, volume is always used in meters cubed in the ideal gas equation, and it's already given to you that here, and so that is the number we'll use for the volume. So that is 3.5 times 10 to the minus 3. N is the number of moles, and that, as you can see in the question, is what we're trying to work out. So let's put a question mark there. R is always the same, that is 8.31. And temperature is given to you here, but that is in Celsius, not Kelvin. Now, to convert from Celsius to Kelvin, you have to add a number to this temperature, and that number is 273.15. So you're going to do, for the temperature, it's going to be 273.15 plus 31. So that's going to give us a temperature in Kelvin of 304.15. Now that number isn't given to you in the exam, so you have to remember that you add 273.15 to any Celsius temperature to get it in Kelvin instead. Now all you have to do is rearrange the ideal gas equation to get the number of moles by itself, which is N. So to do that, we're going to have to divide by RT to leave N by itself on both sides. So N equals PV divided by RT, and that's going to equal P, which is 100,000, times V, which we know is 3.5 times 10 to the minus 3, divided by, so I would do that in brackets in your calculator just to make sure that that's done first, divided by R, which is 8.31, times T, which you've worked out to be 304.15. And that gives you a total number of moles, sorry, that gives you a total number of moles of 0.138. Now, as I said, there's no units for that because number of moles is just a number. And notice that I've put this answer to 3 significant figures, and that's because generally in your questions they'll give you the number to 3 significant figures. You'll see the volume is to 3 significant figures, and also the pressure. The temperature hasn't been, but as a general rule, always put your answers to 3 significant figures, and then you're guaranteed not to lose marks for rounding too far. So now we're going to do something that's very important and learn about how to convert the units for pressure, temperature and volume. As I said before, they will not always give you the most convenient units to work with. They'll expect you to at least convert one of the units, if not 2, and maybe sometimes the answer to the correct units. So first let's deal with volume, because that's the most difficult one. So the volumes that you'll be given are either centimetres cubed, decimeters cubed, or meters cubed. So to go, the difference between all these 3 measurements is a factor of 1,000 between each pair. So to go from centimetres cubed to decimeters cubed, you would need to divide the number by 1,000. To go from decimeters cubed to meters cubed, again, you would divide by 1,000. That means that to go from centimetres cubed all the way to meters cubed, which is sometimes what you have to do, you would need to divide by 1 million. So that's 1 followed by 6 noughts. Similarly, to go back again, to go from meters cubed to decimeters cubed, you would times by 1,000. to go from decimeters cubed to centimeters cubed, you would also times by 1,000, and therefore to go from meters cubed all the way back to centimeters cubed, you would times by 1 million. Okay? Then pressure, the only things you need to convert between are kilopascals and pascals. And to go between these, to go from kilopascals to pascals, you would need to times by 1,000. And to go from pascals to kilopascals, you would then need to divide by 1,000. Finally, there's temperature, and as we've already discussed, temperature you have to add a number. So we've got Celsius, degrees Celsius going to degrees Kelvin. To go from Celsius to Kelvin, all you do is add 273.15, and to go from Kelvin back to Celsius, you take away 273.15. It's very important that you remember to convert your units before you start calculation, and if they ask you to give your answer in a certain unit, then you must convert if you need to anyway. And I hope that gives you a bit more insight into the ideal gas equation.